Welcome to another mathematics presentation. So in this presentation, we are going to answer a question that came in mathematics paper 2 for 2024. So this is the question right here, and this question is coming from trigonometry. The question reads, the diagram shows a triangle PQR in which PR is equal to 8.9 centimeter, QR is equal to 12.5 centimeter, and PRQ is equal to 130.6 degrees. So this is the diagram showing angle PQR. So PR we have been given 8.9 and the QR we have 12.5 centimeter. Then angle PRQ is equal to 130.6 degrees. Calculate A1 PQ. So they want us to find the length or the distance from P to Q. So this is the distance that they want us to find. Now, how can we find this distance? So it's simple. First of all, we need to identify what type of formula we are going to use because this is a non-right angle triangle. So to find the distance PQ, we can either use the sine rule or the cosine rule. Now, looking at what we have two sides, this side and this side. Then we have an angle right here on the middle, in between this side and this side. So the moment you spot this side and this side, and then an angle, and they ask you to find this distance, just know that you are going to use the cosine rule because you need to find the third side. Okay, so we know that you are going to use the cosine rule. So here we have P. So the corresponding side, this side, you are going to have a small letter P. Here you have Q. The corresponding side here are going to have a small letter Q. Here we have R. The corresponding side here are going to have a small letter R. So let's see how we can answer it. So here we have small letter R, and this side you have small letter P, and this side you have small letter Q. So we are using now the cosine rule. So since we are finding PQ, okay, PQ presented by small letter R. So we are going to start our formula. We say R squared is equal to, so we have P, then we also have Q. Okay, so we are going to write P squared plus Q squared minus 2PQ. Okay, minus 2PQ. So remember this formula. Then we say cos R because we have an angle right here on R. So from here, we are going just to substitute. So this one, PQ presented by R, is what we want. So R squared is equal to, so P squared, so P is 12.5, this side. So you write 12.5 squared plus Q is this side, which is 8.9. So 8.9 squared minus 2. In brackets, I'll put the value for P, which is 12.5. Then again in brackets, I'll put the value for Q, which is 8.9. Then cos. So where there is R, we put an angle, which is 130.6 degrees. Now from here, we are just going to find the values. So we are going to write R squared is equal to, so you just need to find 12.5 squared. Okay, so 12.5 squared, what value are you getting? Remember, this is paper 2, so there is need for you to use a calculator. So 12.5 gives us 156.25 plus, then we have 8.9 squared, which gives us 79.21 minus, so we can do the multiplication here, 2 times 12.5 times 8.9. Okay, give us 222.5 cos 130.6 degrees. Then here we are going to do this. We will say R squared equal to, so we can add these two, we can add this and this. Okay, then we subtract the product of this, 235.46 minus, so we find the we say 222.5 times cos 130. It's giving us something like this. So this is what we're having once we punch 222.5 cos 130.6 degrees. This is giving us negative 144.602, 031, 076, 476. So now there's a negative, so it's a plus. So add 235.46, negative, negative, positive, plus this value. So you're going to have something like this. R squared is equal to, so this will give us 380.257.263.341, then 652. Okay, now remember this one is r squared, so you need to find the value of this r, of which you are going to introduce a square root. Even this side we're going to do the same, introduce a square root. So this 2 and the square will cancel, r equal to, so now we just need to find the square root of this number. Okay, so the square root of this number will give us, so this is our square root, r is equal to 19.500,186,238,6402. So remember, if the degree of accuracy is not specified in the question, leave your answer correct to 3 significant figures. So therefore, r equal to 19.5. So 1, 2, 3. This number 0 is less than 5, so it can't round up 5. So 19.5 centimeter. So this was our distance for PQ. Okay, so we say now therefore PQ equal to 19.5 centimeter. So we now come back to our question. We know the distance here was 19.5 centimeter. Let us now look at our question 2. Alright, so we have just answered this one. Our question 2 is saying calculate the area of triangle PQR. So we need to find the area of triangle PQR. Okay, triangle PQR. We need to find the area of this triangle. So to find the area of this triangle, we are just going to say, remember PQ, I've said this is 19.5. So the area of this triangle is going to be half times, so we have this side P, we have this side Q, half times P times Q, then sin R. This is the formula. So area equal to half times, so P is 12.5, then Q it's 8.9 times sine, where there is R and angle is 130.6, so 130.6 degrees. So area equal to, you can just compute everything on your calculator. You can just compute everything on your calculator. Okay, let's see what you are going to get. Alright, so when you compute everything on your calculator, you are getting this value 42.234 and 466, 470, 502, then 7. So remember, area equal to, if the degree of accuracy is not specified, leave your answer correct to 3 significant figures. For answers that have to do with degrees or angles, you leave them to 1 decimal place. So this one will say 42.2, okay, square centimeter, because this is area. So this is the answer for our question A, Roman numeral 2. Alright, so let us now answer our third question. Find or calculate the shortest distance from R to PQ, from R to PQ. So the shortest distance will come from this R up to this line PQ. So this is the shortest distance that we need, SD, shortest distance from R coming on down here to PQ, this line right here. So to find the shortest distance, what are you going to do? Okay, so this one is very easy as well. So to find the shortest distance, this is the third one. So you say shortest distance is equal to, So you're going to say 2 times the area over the distance PQ, because this shortest distance from R is coming to the line PQ. So we're going to use the distance for PQ, which will be our denominator. So in this way, we are going to have, so we say 2 times the area. What is our area? Our area is 42.2 over, what is our PQ? Okay, it's this one, which is 19.5. 19.5. Now from there, let us just say shortest distance is equal to, so we just need to multiply. We just need to multiply, okay? And this multiplication, we are just multiplying, we say 2 times, okay? 2 times 42.2. So this one gives us 84.4 over 19.5. So this answer, then we divide by 19.5. Okay, then we divide by 19.5. So the shortest distance that we are getting, let's just round it off to 3 significant figures. So we are going to have 4.3. So you can see this 2 is the one that is making it 3. Now it will be rounded off by the next number, which is 8. So instead of a 2, it will be a 3. Then we put centimeter. So the shortest distance there was 4.33 centimeter. So we can write here that our shortest distance that we have is 4.33. Okay, so we now come and answer our last question. In fact, it's not our last question. Solve the equation 2 sin x is equal to 1 for 90 degrees less than or equal to x less than or equal to 270. So how can we solve this one? Okay. All right, so here is our question B. We need to solve this equation. This is the trigonometric equation. Then we have this range. We have 90 degrees up to 270, meaning that all the angles that we are going to find, they should lie between this range that we have been given. So what we are going to do is this. So we need to solve. So first of all, we are going to divide by 2 so that this 2 and this 2 will cancel. Then we have sin x is equal to half. Now from here, we need to find the basic angle, which will be presented by alpha equal to, so we're going to find the sine inverse of half, or the sine inverse of 0.5. So here the basic angle is equal to, so we need to find the, we press on our calculator shift sine inverse of 0.5, and this gives us a 30 degrees. So this is just our basic angle. So you can see that sine is positive. So we need to find the quadrants in which sine is positive. So in the first quadrant in Q1, okay, in Q1, the angle is going to be 30 degrees because in the first quadrant, all angles are positive. Then sine is also positive in the second quadrant in Q2, okay. So in Q2, to find the value of theta, we are going to say theta is equal to 180 degrees minus the basic angle. So here we'll say theta equal to 180 degrees minus the basic angle, it's a 30 degrees. So this will give us 150 degrees. This is our value of theta in the second quadrant. So these are the only quadrant where sine is positive. Okay, in the first quadrant where all angles are positive, and in the second quadrant. So now you can see the angles that we have. We have a 30 degrees. We also have a 150 degrees. So looking at our range, we have 90 degrees, then we have 270 degrees, meaning that in the first quadrant where we got a 30 degrees, we are not going to include this angle. So we are just going to say therefore theta, okay, theta is equal to 150 degrees. So this is the value. Okay, that is the answer. We have only picked this one. It's the one that is lying between this range that we have been given. Okay, so let us now look at our last question. All right, so this is our question C, which is our last one. We need to simplify 3x power 3 minus 6x power 2 over x power 2 minus 2x. So first thing, we look at our numerator. What is the highest common factor in terms of the numbers? We have a 3, we have a 6. So 3 is the highest common factor of 3 and 6. Then what else? We have x power 3 and x power 2. So since here is x power 2, here x power 3. So I can say x power 2 is the highest common factor in terms of the letters x. So from here, I start dividing. 3 into 3, it's a 1. X power 2 into x power 2. So x power 2 into x power 3, just remain with x. Minus 3 into 6, it's a 2. X power 2 into x power 2, it's a 1. So we just remain with x minus 2. Okay? Over, when you look at the numerator right here, we have x squared minus 2x. So x is common. Factor out x. So I remain with x minus a 2. Then from here, we can see x minus 2, x minus 2, these are common. We can cancel and remain with 3x squared over x. Now from here, we can, this is 3x squared. You can say x here 1, x here, we just remain with x. So we are going to remain with 3x. And this is our answer. So thank you so much, everybody. We've come to the end of our presentation. Have a blessed day.